Good evening, everyone. We are starting the discussion on Biomass Conversion and Biorefinery course. Unfortunately, till now no one is joined, but we'll start the discussion. And if someone will be joined in between, I will let him or her to be joined. And today we are discussing fifth time on the Biomass Conversion and Biorefinery course. We will cover the assignment questions part of the week 5 content, as well as we'll go through the week 6 content that will be helpful for you to solve the assignments. So now I want to share my screen. Okay. I hope so you can able to see my screen. Now I am opening to the presentation for the today's discussion. So we'll wait for 1 minute at least, and then we'll start. If someone wanted to join, then okay. So we'll discuss the week 5, which is physical and thermal conversion processes, as well as week 6 microbial conversion processes. So I don't want to waste the time, so better we can start. Wait 1 minute. Okay. So week 5 content is the physical and thermal conversion processes, and week 6 is the microbial conversion processes. This course is taken by Professor Kaustuba Mohanty from IIT Guwahati, and the part covered in this 2 weeks content is available as a notes from lecture note 13 to lecture note 18. So again I am giving my brief introduction again, so in case you want to contact me, you can contact me. My name is Bhavi Kumar Mahant. I am a PhD scholar at IIT Madras in the chemical engineering department. My mail ID as well as mobile number, so this is also my WhatsApp number, so you can contact me on this if you have any doubts, or at the same time if you want to discuss something, and at least not regarding to the assignment and all, but if you want to discuss in general with respect to course, you can contact me. Now first we start with the content of the week 5, in which we will go through the already given answers were already given. Okay, so today we'll cover the week 5 content as well as week 6 content, and we'll go through the assignment answers of the week 5. We'll not go through the whole content, as you already covered this content in the last lecture. So week 5th was the physical and thermal conversion processes, and as you know that physical processes are useful. The main thing is to separate it cellulose, hemicellulose, and lipid or lignin. So in that we discuss about the physical and thermal conversion processes, where we went to the so many processes like drying, dewatering, size reduction as separation and densification kind of physical processes. At the same time, we also discuss about the pyrolysis and many other processes. So the questions there are many different information over there, depending on to the biomass, depending on to the final output, final product, and depending on to the available characteristics of the biomass, as well as process availability and easiness of the process, we will choose the process. And here you can see the different biomass is mentioned with respect to the moisture percentage available. As you can see, 95.3% is the highest moisture is available, and 6.5 is the lowest. So the first topic was in the week discussion was the drying. So in the drying of the biomass, we saw that the one concept is the dewatering, another is the drying, where dewatering is we'll remove all of the moisture out of it, while in the drying, whatever the moisture we can able to remove by vaporizing it, by providing the heat energy, that is comes under the drying. And these are the different dryers. For your understanding, this is a rotary drum, and this is a flash flash dryer, fluidized bed dryer, ring dryer, and spray dryer. So we'll not go to the much detail. So in that, size reduction of biomass is the second topic, and there was one questions in the assignment on from that. The question is from the dry shredder. So this is how dry shredder actually looks like, and this is their schematic diagram. But if you can't able to read from the slide, then this is the content. The question is, in the dry shredder there are different types of depending on the arrangement, there are different types of hammer mills are there. So actually these are the hammer mills, where inside it it is move with the help of the mechanical devices. It has the hammer kind of different shafts, one shaft in that different hammers, so which can be responsible for the reducing the size. So in that, the most common types of machines are the vertical and horizontal shaft hammer mills. So one which can horizontally mounted the hammers on it, and another there is a vertically mounted hammers on it. So the common type of the question is, the common type of dry shredder used for the reducing the size of biomass is vertical as well as horizontal. The answer is both B and C. Another topic was the drying, as we already discussed. In the drying, the question asked is the moisture content of biomass dash the boiler efficiency dash. The increase in the moisture content of biomass dash the boiler efficiency. So if the moisture content will be increasing, then what it affect to the efficiency of the boiler. So as we know, if our biomass has a moisture content, and then if we put it into the boiler, so requirement of the process is to remove the moisture. So if we have lower amount of moisture or moisture content in our biomass, then we don't require the higher energy from the boiler, higher energy output from the boiler. But if we have higher moisture content, or moisture content is starting to increasing, then it requires the higher energy from the boiler. So overall efficiency, which is the how much output we are taking from the boiler and how much energy we are giving to the boiler, overall the input will be increased, so efficiency will be reduced. So answer is the as while moisture content will be increases in the biomass, the boiler efficiency will decrease. Now there is another topic is the densification of the biomass. Densification, in the simple word, we are increasing the density of our biomass. So we are pack it into the some kind of by giving to some kind of treatment, mechanical treatment. So it can be densify itself, or we can increase the bulk density of our biomass. So in this, this is a simple process where we put it into the one metal part, and we providing the piston kind of material is there. We are providing the force up from it. So as you can see, if you put the initial level, there are many spaces are there in between the biomass, and biomass the particles are perfectly in the sphere. So when we are trying to applying the force, first this space will be reduced, and whatever the void space or available space will be reduced, and then we again apply the force up to the particular limit. Then the particle size is also trying to deform, particles trying to deform, and at the end you will get this. Someone wanted to join. So currently we are discussing the week 5 assignments, and then we go to the week 6 content. So at the end, after applying the final applied force, you will see that this kind of material it's look like. So it is too much interlocking in between, all the particles are deformed their size, and this is how you can see that we can densify the material, or we can increase the density of the material. So the question asked was, the density and moisture content of the bell straw is in the range of what? And in the same densification concept, it is mentioned in one of the slide from the professor that it has density of 70 to 90 kilogram per meter cube, and it has a moisture content in the range of 10 to 15 watt percent. As you can also able to see it from here. So this is the actual density you can see, and when you apply this densification, then it bulk density of pile straw, which is the final product, which is only 5 to 15% of this density range. So from 90 kilogram to it's remain up to only 3 kilogram per meter cube. That's it, or even less than that. So this is how densification works, and it will be helpful to enhance the surface area, no, not surface area, enhance the characteristics of the biomass to produce to process into the next stage of operation. And now we switch to the topic of gasification. In the gasification, basically, if you see that food waste has to be gone through the different kind of processes, whether it is a physiochemical, whether it is a biological. So in the last week discussion, we didn't consider this physiochemical and biological in detail. So in the week 6 today, we'll discuss about the biological thing. Last we discussed about the thermochemical. In the thermochemical also, we can directly provide the incineration or combustion. Then the pyrolysis, without the presence of oxygen, we are providing the heat, and the reactions are going on, and the gasification process and hydrothermal carbonization process, out of which every process has the main product as well as byproduct. So we don't need to go into discuss each and everything again, but basically, if you see the food processing, then first food processing, why I am putting this slide here, because there is one question from the pre-consumer waste and post-consumer waste in the assignments. So better we'll see that here. So if you have unprepared food, if you just consider the restaurant model here. So if you're in the restaurant, we have raw materials. So we are giving the adding the water, and then when we are heating, the water will be removed. Then some excess material is there, or some spillage is there from the raw material, which is going into the pre-consumer food waste, which is the waste generated during the preparation of the food. Once the food was prepared, then we either if we are in the restaurant, then directly we can get the food from the waiter. If we are at home, and then we can go for the Swiggy, Zomato kind of services, that then we'll get the food. Out of that also, you can see that not everyone complete whatever the amount of food they take. So there is also some waste materials got generated, that is known as a post-consumer waste. So we'll see in the next slide. So what was the question which was asked from this slide, but this is the last time we discussed the in simple way how this gasification works. So we have the feedstocks of coal, biomass, petroleum, coke waste. It will go into this gasifier. In the gasifier, at different temperature zones are there, and the different processes are going there. We'll not go to detail. We'll see some 1-2 slide in the upcoming, depending on the questions based on it. So you will get the solid byproduct from down, whatever the gases you will get that. For the combustion process, you require the steam. So you get the steam from the steam generator, steam turbine, and you will use it. And other than that, for the pyrolysis, we have to give the control amount of oxygen into it. And depending on your process or gasification process, or different kind of gasification has many different processes. So depending on the process, what is the amount of oxygen required, you have to provide it from here. So in the presence of steam and oxygen, the reaction is happening over here, and temperature is going maintained. And from out of that, once you get the final steam with product stream, which you will go fed it into the different separator. In this particular separator, you are removing the particulates material which is here. In the another separator, you are removing the sulfuric acid, and then it will pass through this final separation, where you will get in the at the one end you will get the syngas, which is a mixture of CO and H2, which you can directly use as a fuels, and you can use as a precursor for the making some different chemicals. And in this particular final separation, you will remove the this is you can directly get without any separation. If you want to remove hydrogen out of it, so you will go for some membrane separation, where you will get the hydrogen. You can use it as a transportation fuel, which is not that much commercialized till now, but yeah, it may be the one option. In another option, you can generate the electricity of hydrogen. That's why you can use it into the fuel cell, and you can find the electric power out of it. So another than that, the syngas which we directly got, which we can which we use for the chemical production, as well as we can use the steam gas to run our combustion turbine. So in the combustion turbine, why it is required? So we can generate the electricity, and that combustion turbine we can use it for the generation of heating of the air. So whatever air we can take out of it, we can heat it, and at the end we can also generate the steam out of it. So whatever the water, if we can use it and convert it into the steam turbine, so we can use that steam in our original process. So at one, this is a whole cyclic system, and we can minimize the wastage of the energy at any step. So this is how a gasification looks like. So we'll not go into detail, but I just want to show you what is the process and how it is looks like actually in the industry. In the industry, you can't find only one simple way of doing it. There are many complications, complicated recycling streams, product stream, byproduct stream. So you can get at the end the maximum amount of product out of it. Okay, so now we go to the next slide. So the question asked from the gasification, which we cover here. So the question is the temperature maintained in the pyrolysis zone of the gasifier is. So from the slide of the professor's slide, so in the gasifier, the uppermost part is the drying part, as you can see here. In between the pyrolysis part, and at the in the down side you will see the combustion price. So if you go to the very latest one, then you can see the four different parts, even in the 5 also in some case. The upper part is the drying zone, where temperature is 100 to 150 degrees centigrade. Why temperature is lower? Because heat we are providing from the down, so in down the temperature is higher. In between, in this advanced process, we are providing heat from here. So combustion and cracking has the highest temperature, 800 to 1200. Pyrolysis is 200 to 500. So this is particular process. But if we go into the much general discussion of the professor, then the pyrolysis has a temperature range from the 315 to 1000 degrees centigrade. So that is the answer of this question. And there are every step there are many byproducts are generated, and there are many number of reactions are going on that we don't need to look into it currently. Now there were questions from the types of gasifier. So we started with, there is one important types of gasifier, which is a which has a fixed bed, which is a process, which is arrangement of fixed bed kind of thing. In this, if you just go into the many other detail, then there was a fixed bed up, and these two both are the fixed bed gasifier. So here also you can see that updraft gasifier and downdraft gasifier. So what is the difference? If our gasifying agent is coming from the down bottom, and our fuel enters from the up, then it is known as a updraft gasifier. If our fuel is coming from the up, and as well as gasifying agent, wait, what is mentioned by the professor, because we not follow some other figures. This will just for in your help understanding. So in the downdraft, both fuel and gasification agent occurs from the top. So in the downdraft gasifier, fuel as well as gasification air is, here it is mentioned in the middle, but it is also from the top. This is some more advanced and modified design, but in actually, as you can see that it's not actually top, it is in middle only. So this is a downdraft, and updraft has air from down and fuel from up. This is the fluidized bed, moving fluidized bed kind of gasifier, and this is the entrained, this is circulating fluidized bed, and this is the entrained flow gasifier. So in the question is an updraft gasifier, the gasifying agent enters from the down or bottom, and the fuels enter from the top. So as you can see here, so this is the answer, bottom and top. Now we'll go to the next question, which was asked in the fifth assignment. In that, we need to understand pyrolysis types and reactors. So we'll not go into the detail. Last time we visited this topic and we discussed in detail that what are the different types of pyrolysis and how it is reactors are affecting. So if we talk about the pyrolysis technology variant, then there is a one table which is shown from the professor. There are many different kind of processes are taking place in the name of pyrolysis. As you can see here, if you talk about the carbonization, say it takes to uh, it takes days of time to be completed. And just a second, I am getting the call. So carbonization requires days, and the product you will get is a charcoal. Temperature 600 degrees centigrade. Like conventional is 5 to 30 minutes. So flash gas and flash liquid require less than 1 second of residence time to complete their whole pyrolysis process, and at the end you will get the bio or chemicals or gas in out of it. So what was the questions? And if you want to see the different types of pyrolysis reactor, then the fluidized bed reactor, as we just see, fluidized bed is there. So we are providing the circulating gas. So our bed is a little bit fluidized in the fluidization process, and you will get the product. It will go into the cyclone separator. The solid antenna is removed as a char, and you will go to the final product as a bio oil. And the circulating fluidized bed, where fluidized bed is moving, so if bed is moving, so we need to remove it. So it's a two cyclone separator. Aberrative plate reactor, where we are providing the biomass and their rotating plates are there and heating is provided. And then screw, where your biomass is fading into the reactor as a screw. In this particular screw only we are providing the heat and you will get the product. Rotating cone reactor, which is very famous kind of reactor. You are putting the biomass from the center and then it will rotate on its axis. And cyclone reactor, these are the important reactor. What was the question? The question was the retention time for vacuum pyrolysis is what? So as you can see, if you talk about the vacuum pyrolysis, the retention time is 2 to 30 seconds. So this is your answer. So that's it for this one. We are not going through much detail. Then the rotating cone reactor, if we talk about the rotating cone reactor, then you can see that we are just discussed the biomass is come from the top and this got rotating and we are providing the heating in between. So whatever it will enhance the mass transfer and the reaction which is taking place inside, and efficient heat transfer will be there, so you will get your product very easily, and combustion and pyrolysis reaction will be go in a much more smoothly. Another, this is a vacuum pyrolysis reactor where we are providing the biomass, but we are maintaining the whole reactor under the vacuum. So we are using this vacuum pump, and this vacuum pump will not get some product or some biomass solid particles. That's why some separator from in between antenna is required. Other than that, why we are using vacuum pump? So you know that temperature and pressure are interrelated. So if we have the higher pressure, then the boiling point is also higher. If our product is degradable at high temperature, so we can use under the vacuum, so its boiling point got drastically reduced and then we can operate the process. So the question was, in the pyrolysis process, the mechanical mixing of biomass and sand is done in which type of reactor? So uh, if you have read the rotating cone reactor details, then it is mentioned in that the rotating cone reactor, unlike the fluidized bed reactor, the rotating cone reactor requires the mixing of biomass and hot sand mechanically. So in this you will mix your biomass as well as hot sands. So that's why the answer is a rotating cone reactor. Now there were two technology, DBT, ICT, Department of Biotechnology, and Institute of Chemical Technology, 2G ethanol technology. So where they put this technology at Kasipur, Uttarakhand, and the major advantage of this technology is it can use for the flexible feedstock. That means any kind of biomass you can put it inside, and you can, this is the process like lignocellulosic biomass is there, pretreatment, saccharification, separation and fermentation, which is a general process which follow in all this biomass based technology. when we because we if we separate out the sugars, and from sugar we can convert it into alcohol and other by using fermentation and other processes we can convert it into the alcohol and other many other products. So what was the question? So which is the following is false for the DBT-ICT-2J ethanol technology? That was the question. There are three options: low conversion, recovery of chemical enzyme is possible or not, and slow process, which means that it takes more than 24 hours. So these are the three questions. And what is the false, or what are the false answer out of it? So in this technology, professor explained that it is a continuously processing required for the biomass rejection to fermentation, and converts biomass to the alcohol within 24 hours compared to the other technology which is taking 3 to 5 days. And in other place he mentioned that fractionation to sugar lignin rapid, and it is by using a rapid and efficient process less than 24 hours it has a high conversion, and we can again being recycle whatever we are using, there is enzyme or chemicals. So everything is possible. Conversion is higher. So here row conversion this is the answer. Another this the recovery of enzyme, yeah, it's possible. Slow process, it's not slow process, it is taking less than time from the 24 hours, so it is a fast process, rapid process. So answer is both A and C. Now there is a question where we just before discussed one pre-consumer and post-consumer food. So in that we mentioned that if our food is in the form of raw material and we are preparing the food, so while preparing the food, preparation of the food, whatever the waste generated is a pre-consumer food waste, and after preparation whatever the waste we are generating, it is a post consumer food. So here you can which of the following can be identified as a pre-consumer food as well as post-consumer food. So so here you can see that cafeteria is obviously it is a not pre-consumer, it is a post-consumer, whatever you generated cafeteria. So these both are wrong. Here you can see commercial agriculture waste. So agriculture waste is obviously before just making the food, so it is a pre-consumer food, as well as in cafeteria it is a post-consumer institutional cafeteria. So answer is commercial post. Here it is mentioned also residential institutional. So you can go through it if you want to see more understanding. So BTG process. So BTG process is developed by the National University of Twente in Netherlands, and this is a fast pyrolysis process, which is a process like this. So the biomass is put it into the reactor, and we are using the rotating cyclone rotating corn reactor, where we are mixing the sand and all. So by using this we are adding into the final reactor. Here air will be thrown into it, and the to presence of hot sand we are getting the whole pyrolysis process. You are getting your gases product into the gases. It will go through the separator, cyclone separator, as will be removed, flue gas will be generated, which will you use for the steam. And at the same time from this cyclone separator also vapors were generated that will be passed through this absorption, where the temperature is maintained using the cooling tower. So you are reducing the temperature, and you will get the bio oil out of which, and whatever the steam or gas generated you will send to the in the fuel gas for the further processing. So the question was the reactor employed in the BTG fast pyrolysis. What is the reactor? As we mentioned, this two is a part of reactor which is known as a rotating corn reactor. This is actual reactor, but more separation and other thing is going for the more volume. This in this reactor, which is a bigger volume, or which is maybe you can say the fresh separator. So actual reactor is this one. So which type of reactor is a rotating corn reactor? The answer is a rotating corn reactor. It is mentioned into this slide also. Now I think all the 10 questions got covered. Now we'll start discussing to the today's topic, or week 6 discussions, which is basically microbial conversion processes. So microbial conversion process, we just see the thermochemical process in which pyrolysis and other details were there. So as you can able to properly read this slide. So this I copied this. Sometime I have to be put the content from the professor's slide, because the questions of the assignment is directly from the slides. But I will cover the other topics also, which will be not other topics, the topics in detail, and explain from the other methods, so you can easily understand the reality of the process. And you can basically, you have one sort of information, I will provide some additional information, then you can merge it and you can clarify your doubts. An idea will be enhanced. So biochemical conversion processes allow the decomposition of biomass into available carbohydrates. Obviously, we are focusing on the carbohydrates. Basically, it will be converted into the sugar by using the microbial process. The major processes are the fermentation, as well as biological reactor, anaerobic bioreactions and all. So first, carbohydrate can be converted into the liquid fuels like alcohols, and then fuels and some chemicals. Alcohols are also used as a fuels. It's not like that alcohols are not fuels. In the Brazil and US, ethanol and methanol, it is used as the fuels. Even there are some vehicles are there which can be run on the 100% methanol also, but it has some another issues in the engine, so they are blending the mainly ethanol methanol in their gasoline, or maybe in our what it is a petrol and diesel. They are adding these different fuels. So so liquid fuel as well as biogas, you will get obvious option is there. When you are going for the microbial conversion, you will get the biomethane or the methane, and it is the most important product. You can use it as for the energy generation, or as well as in the cooking or kitchen purposes. Now, in this process, various solvent gaseous metabolites, including alcohols, volatile fatty acid, methane, carbon dioxide, hydrogen, can be produced to pure and complex microorganisms. Now, microorganisms means you need to understand these are the bacteria and fungi and other microorganisms. Organisms are the microorganisms. That means literally mean the living organisms. Which size has in the micron size. So they are very much complex. If you are giving them to the anything which has organic material in it, so they are surviving on that particular materials. So they are consuming it as their food, and you will get the final product out of their processing from their microorganisms only. So now your main focus is to how to choose the microorganisms and how to maintain the particular conditions or physical parameters where these microorganisms will be efficiently convert your whatever the biomass is there into the final product. Some of the processes that are having tremendous commercial application are anaerobic digestion. Anaerobic digestion means anaerobic means aerobic means in the presence of air, anaerobic means in the absence of air, so you are not providing oxygen into it, and digestion is the process which we are using. The fermentation, microbial fuel cell, microbial electrochemical systems, and composting are the answers. So anaerobic digestion is the first topic. In that, it is a multi-step biological process. If you just want to see that what is the actual anaerobic digestion, so you are using the different feedstocks singularly or in the combination of the another feedstock. So they are kind of two menus: wastewater, biosolid, food waste, other organic solids, and any kind of energy option you can use into the anaerobic digestion system, where you are using the microorganisms and you will get the products digestate what you are getting. So the digestate what means, so whatever the remaining material or manure at the end of the process, it can be converted into the horticulture products, where you can use it as for the manure and soil enhancement. Then crop irrigation you can use, other products, animal bedding you can use for animal bedding, and organic fertilizer. These are the major advantages of the final digestate. On whatever the gaseous material you get from this digestion, which is a biogas, which can be used for generating the electricity for heating purpose, as a directly in the vehicular fuel, like we are using the CNG, we have to just purify it from the methane, and you can also use as a renewable natural gas, and some bioproduct feedstock also you can use. So mainly this anaerobic digestion consists of four basic steps starting from the hydrolysis, acidogenesis, acetogenesis and methanogenesis. All different processes required. Okay, so whosoever just joined, we discussed first all the questions of the week 5, and that was how the answer of all the assignment question of week 5 came. And now we just shift to the 6th week discussion. We started with the anaerobic digestion. We just discussed about how the micro processes are taking place. If you talk about the anaerobic digestion, so many kind of biomass you can take it, and you will get two different product. If you go for the gaseous product, and it will have mainly methane, so it can use for the many purposes. I don't want to go for them again and again, so otherwise it will take time to cover the all content. You can see into the YouTube video. Whatever the digested final product is there, you can use it in the fertilizer, horticulture product, and many other products. But basically anaerobic digestion has the four different process stages. One is the hydrolysis. You can see with addition of water, we can separation of the raw material. From the acidogenesis, we are using the acid material. Acidogenesis means we are generating the acid out of it. Then acetogenesis is generating acetate or acetic acid out of it, and then you will convert it into the methanogenesis, which is you will get the methane out of it. All the four steps require the different kind of microorganisms, different kind of reactions. Basically the entire process happening without the oxygen, so these reactions break down the organic macromolecules into simpler molecules and leading to the generation of the biogas. So biogas is not only pure methane. Generally what we are getting from the nature gas and all, it has more than 85% concentration composition of methane only, but in the biogas it is 60%, or it vary depending on your process as well as your raw material and the final product. So basically it is mixture of methane and carbon dioxide. So and if you just see that in feedstocks, any kind of feedstock we are using, but anaerobic digestion can be carried out at the mesophilic, which is basically 20 to 45 degrees centigrade, or in the thermophilic range, which is the 45 to 60 degrees centigrade, depending on the condition. So what is the condition? Depending on our microorganism, which can survive at whatever temperature. So this is how, if we just see the anaerobic digester, so we can, in the same, we just saw one pictorial representation here also. So whatever the livestock waste we have out from the kettles, we have the energy crops, we have wastewater, we can have food waste, everything can be going to the anaerobic digester. So it's not like the last time we see the thermochemical process, where in the pyrolysis and all, not every process is suitable for all kind of waste or biomass as an intake of their feed or feedstock. But in digester, anything which has organic part in it, we can use it. So how we can use it? So as I can see, just I need to take one call, just 1 minute. Yeah, actually I'm busy in one meeting. So can you come to the fourth floor and give it to someone on the 430? I am in the nearby room of 430. If you would not find anyone, then let me know. 430. That is a my lab only, but I am not in that particular place. Okay, you can. Okay, you can go. Okay, sorry, that was an important call. So in that, the all raw material can go into the AD anaerobic digester, and we see biogas as we use a heat electricity biomethane for use as a fuel and gas grid, and digester as a fertilizer, soil amendment and livestock bedding. Now, so many factors including the retention. What are the important factors in on there? It is the question why I am covering the particular small topics or particular these topics, because we can't able to cover the whole 3 lectures. And what are the first I will cover what is the much important for the solving the assignment questions, and then we'll discuss later bit in much more detail. So in that, first in the if we talk about the anaerobic digestion, then the hydraulic retention time, organic loading rate. So how much organic things you are putting. So as we discussed that organic things we can use as a feeding for the microorganisms. So organic means anything which has carbohydrates in it, we can put it into the digester, and then it can be, the microorganisms rely on it, feed on it, and they convert it into the other different kind of final products. So it depends how much organic loading rate is there. Substrates, which kind of microorganisms you are using in the fermentation process. So substrates containing excessive inhibitors such as ammonia, sulfide, metal organics may make the fermentation process more unstable, resulting in a low yield of biomethane. In our substrate, in the final biomass, whatever we have, substrate is not organic. Sorry, it is a biomass. Whatever we have the substrates, if it is has excessive amount of ammonia, sulfide, and some metal or some organic, that depends on that will be not, if it will be harmful to the microorganism, then your yield will be lower down. Then what happened during the anaerobic digestion process? So basically the process, when it is happening, many byproducts that are produced. So some, because you can understand the microorganisms will work and they will convert into the some products. That product may be which will be helpful or not, that we have to decide. And depending on our particular environment and biomass composition, we'll take some product. They may be inhibitors and toxic compounds. So we need to see if some toxic compounds will be generated, which will be difficult for microorganisms to survive in that environment, then we have to remove that kind of product also. Like you suppose hydrogen sulfide gas or some sulfide materials which are harmful to our final for microorganisms, then we have to remove continuously out of it. So what way they are inhibiting basically. So how they are inhibiting, these inhibitors will be working. So beyond certain limit, if they are getting produced, and again let us say produce and remain in the environment. So if they produce, it's fine, but if we can't able to remove it from the environment, then they will hamper the growth of the microorganisms, as I told you, and their metabolic activities will be affected. So in any such fermentation process, including anaerobic digestion, and such type of inorganic compounds are for, so our requires to remove it in the frequent basis, and we have to maintain the concentration inside the equipment a very very small level, whatever the inhibitor and toxic compound is there. Now apart from that, these are some important we are discussing points. Short hydraulic retention time, so that might lead to the risk of washout of microbial communities. Now hydraulic retention, at the first process hydrolysis, so we are addition of means water is there, and we are separating out our carbohydrates and other materials. But if we use more amount of in the same more amount of water in it, so our hydraulic retention time is more. Then our final microorganisms are also living organisms that can be wash it out, and they will be died also. So retention time is how much time it will be feed is going to be spent or going to be processed inside a particular reactor. So we have to maintain each and everything. A high organic loading, that means high organic loading rate will be boost the acidogenesis stage. So that means the feedstock is very much enriched with the organic compound. If you have much more organic compound in the acidogenesis process, where microorganisms convert our product many acid as a product, that will be enhanced, and it is known as a rich organic compound. So now you can see, if you started with the complex biopolymer which we have in our biomass. So first, in the first step, this is a whatever we are putting, understand that thing, either it is any kind of waste which is generated from the living entity, so it has a biopolymers. So how can you understand? Protein, DNA, everything is a polymer, which is a biopolymer. So polysaccharides, fats, oils, everything we have in our body, and other animals also have. So in the first hydrolysis step, our fermentive bacteria start working and broken down from this monomer and oligomers. In the last physio process, we saw that it will be converted into lignocellulosic waste. We saw that it will be converted into cellulose, hemicellulose, as well as lignin. Here, this biopolymer got converted into the sugars, amino acid, and peptides in the presence of fermentive bacteria. So it is known as it got more broken down from the monomer and oligomers. Monomers is the only, if you have long chain, only one particle of the chain is there, and oligomers only 2 to 3 particle of chain is still there. Then in the second step, which is known as a acidogenesis, we using the bacteria. Their name is not given, it is always mentioned as a fermentative bacteria. So fermentative bacteria, so the names are also a little bit complicated to be remember and understand, so better we can just see the name is a bacteria. So you will get 3 different things out of this broken down monomers. So as you have sugars, you have amino acid and peptides. So out of it you will get either acetate. So directly from this step to directly get to acetate. Other bacteria is like that, so directly this product is converted into the H2 and CO2 in the mixture of hydrogen and carbon dioxide, and in between some bacteria are there, so in between some intermediate product is generated, which is known as a propionate butyrate. So short chain organic acid, you can see butyrate means has four carbon in it, and it has a 4 carbon chain acid, you can consider that will be generated, out of which this is a acidogenesis process. If the process only do this thing, then we have to use the third stage of process or third phase of process, where we are using the bacteria which can convert it into organic acid into the acetogens, which will convert it into the hydrogen and CO2 mixture as well as acetate. Okay, so acetate means you can consider that esters are generated. So ester is, if you don't remember, then it has this COOH is there. Out of this H is got replaced. Suppose here some chain of carbon is there, so it got replaced with another carbon chain. So this is a ester. So it is acetate. So why it is important? Now we have carbon chain at the end of COOR. So when we have H2 plus CO2, and if we can't able to directly use the hydrogen out of it, because hydrogen is currently we don't have infrastructure to utilize the hydrogen as a transportation in the power generation or electricity generation. So the carbon chain is reacted with it. So whatever the COOR is there, so OO is converted into useful for remove the hydrogen in the form of water, and another water carbon hydrocarbon is there, which is useful to make it in the form of methane, and then methane we can easily use. So for that also it is not directly reacted together, because for the reaction we can react this two separately in the presence of catalyst as well as high temperature. Some reaction is there, but here in the microorganism kind of system we can't go for the high temperature, so we are using some another kind of bacteria which is known as in this process is known as a methanogenesis, which can out of this CO2 can reducing from the methanogenesis, and we can convert this methane and CO2. And other than if you are acetate product, then the process is acetoclastic methanogens, and directly that bacteria itself from acetate you can get the CH4 out of it. Now if we just talk about the first what we already seen, so just go through the little bit notes. So in the first one is the hydrolysis, represent the initial phase of process where very large organic materials are there, fats, carbohydrate, protein. It can convert it into the organic molecules such as converted into the fatty acid, amino acids, simple sugars, monomers and oligomers. It should be noted that the most of the large molecules are further decomposed in the acidogenesis process. So acidogenesis, again this large molecule is converted into the smaller parts. On the other hand, the other byproduct resulting from the hydrolysis stage, including hydrogen acetate, are used in the final stage of the process, that is a methanogenesis. So from the write-up of the professor's slide, if you can't able to understand, so this is how you can separate it out and you can get to know what is the process that is going on. And the second step is acidogenesis, we just saw, and here also from the polymer hydrolysis you will get the monomers. Then another is acidogenesis, you will get some acidogenic you will use some acidogenic microorganisms to convert to getting the product. So what is the acidogenesis? So acidogenesis. So acidogenesis is the second stage of the anaerobic digestion through which acidogenic microorganisms which we are using, which are basically fermentative bacteria. So bacteria which can be helpful in the fermentation. That is known as a fermentative bacteria. Further decompose the product of the hydrolysis stage, producing now they convert this hydrolysis stage product into the acid, but they are also in the same time they also produce ammonia, carbon dioxide, hydrogen sulfide, alcohols, light volatile fatty acid, carbonic acid, and certain alcohols. So there are so many different kind of monomers are there. So when during the acidogenesis process there are many more different range of product is generated. So acidogenesis process only partially decompose the biomass. So for fully decomposition is not taking place. So for a and fully decomposition, then we'll get the methane. So for that acetogenesis process is required. So in the acetogenesis process, employs acetogenic microorganisms catabolizing the products created in acetogenesis process into acetic acid. So first they convert this acetogenesis process into acetic acid. So basically that's why it is known as acetic acetogenesis. So in the ester, as I told you, first they convert it to acetic acid, and out of that ester, and then we will get the final product. So acetic acid is generated in a huge amount. That's why it is known as acetogenesis process. Now this acetogens finalize the breakdown process of the biomass, facilitating the action of the methanogenic archaea to produce methane as a biofuel. And then you will see use the methanogenic microorganisms to produce a methane. So this is the last step of which is known as the methanogenesis, and final stage of anaerobic digestion, during which, as mentioned earlier, methane is generated from the main product of acetogenesis, which is acetic acid and carbon dioxide. So here the small video is there. I don't know that you can hear to the audio out of it or not, but just watch it. It's very small video, and it means I attached two different videos, both are on the anaerobic digestion, but it's a small video. If you can able to hear the sound, just let me know. Otherwise you can see the many videos are there in the YouTube, but by watching also you can understand what is the video is suggested. So anaerobic digestion, it is portrayed as a alternative of land feeding. So currently in India and other worldwide other countries are also using this land filling technology for their municipal waste and other kind of waste, to just food waste and all, so just landfill it. But this anaerobic digestion is promoting it as people are promoting it as a anaerobic as an alternative of landfilling. So obviously you will get the products out of it. So can I get some confirmation that you able to hear the video, what they are speaking in this video? Audio is audible, or if it is not, then also it's fine, I guess. But if you can able to confirm that the video is audible or not, whosoever present in this meeting. So what, it's not audible, okay. So don't worry, it is just mentioning everything and on the screen. The first food waste is arrived on this anaerobic digester plant. From that it is fed into the, as you can see, first it is fed into the size reduction and other process, pre-treatment, and remaining packaging is removed. So we have to remove the packaging also. So whatever plastic material and everything is there, we have to remove, and then it is feeding into the final digester tank. So this is actually how it is look like. So this is a digestion tank, anaerobic digestion, where we maintain the temperature, no air is there, and we maintain the process parameter, and we use the digestion with using the microorganisms, and you will get the waste which can separate into the two main products. So first you will get the methane out of it, okay, and so which we can use it, and you can use it for many processes. So you can collect this methane and you can use it in the power generators. Mainly people are using methane for the power generation, so that is a one option. So particular technology, they are using the whatever the methane they are generating, 90% electricity they are generating, and they are using it for the export to the national grid. That is into the electricity department of the particular country, you can understand, and 10% will be used into the running the whole plant. So this is their estimation. It varies depending on to the process. All that methane also used as a CNG, which we know, or you can also supply to homes and businesses. Now in the homes and business there are two different use. One is in the kitchen or cooking use, just see that, but other is the heating purpose. Because in Europe, you can see Europe, Canada, and northern part of America, the temperature is too much lower, so they require, like we require the air conditioning system, they require the heater in their rooms. So for this methane we can use it in the heater also as a fuel to generate this heat, or that heat is also can be used to maintain the temperature in the factory. That's so this is how this process is fully recycled, and it's we are not have to invest electricity or heating out of the this whole process. We can use the process, and whatever the product we'll get out of it, we can again recycle, and we can recover the energy, and we can utilize into the plant, or digested whatever we created the solid part, which is a high in the nutrients and nitrogen, so which we can use for the agriculture purpose. We know that it can able to improve the soil and increase the nutrients in the land. So this is what we all know, we discuss only, but this is cartoon kind of thing. Now in another video I think some real plant, no, this is also cartoon. But you can actually, why I didn't attach the actual technology of it, but because the video length is more than required, video is more video length is much more higher. So like, and another is timing was time duration of the video is also 9 minutes 10 minutes, so I don't want to waste your time. You can just go in YouTube, many videos are there, but we'll go for the another 2.5 minute video. So don't need to hear anything. This is how this anaerobic digesters are there. This is how its whole process looks like. So this is the first stage where you get the biomass. You can see out of the food truck or something, waste material, food waste is coming. It goes to the so here they mention the temperature and pressure for that particular temperature for particular technology. That's why I added. So 160 degree Fahrenheit for 1 hour they are putting it, and so we are not only use the material from the food, they also use the material from the manure, cattle manure, and they put it into this tank from which can mix it both of the manure and biomass, and then you can put it into the final digester where you are maintaining the 100 degree Fahrenheit temperature, and you can put it for the 20 to 30 days. As microorganism process require higher time, it's not like the pyrolysis or 2 days 3 days, within 24 hours or within fraction of a second you will get the product, because microorganisms are little bit microorganisms, actually living organisms, so they require to complete out the process. All product needs to be converted by degradation and decomposition process. Now once you fill it, then the continuously stirring is going on, mixing is going on, and the microorganism is there inside it, so they are doing their work. They are, and at the end you will get the methane, which is a 60% methane. That means 40% carbon dioxide is there. It needs to be go into the gas filtration. So gas filtration will be purify the methane gas, and then you can use it for the directly from the, this is a turbine, gas turbine. They put direct the gas turbine, and then you will get the electricity out of it. So this is how this kind of processes works. So from the one is a anaerobic thing, and then from that you will go for the, this is a rough estimation of the technology. 2.7 million gallons of gas will be generated, and whatever the waste, solid waste is there, it is put into the storage tank. It will more process for the amount of time, and then also you will also again get the gas that will be again you go convert into electricity, and whatever the solid part you will get, you will use it into the as a fertilizer. for enhance the nutrients into the land. So this is how this process works. It's very easy. We already discussed, or we already learned all these processes in our school science, where we have the gobar gas, biogas plant, so many things were there. But if you just want to see the realistic thing, then in the videos were available in the YouTube, so you can go through and understand how this kind of bacteria is using, or you can read the research papers for that purpose. So you will see the which kind of bacteria they are using, which kind of processes they are through this bacteria taking place, which kind of reactions are going on, what are the products are there, which are the products are harmful to the bacteria, which are not. So this is all about the anaerobic digestion. Another process is much more famous process, which is the fermentation, which we all heard about this fermentation process. So it is an enzyme catalyzed metabolic process, where we are using the enzyme, not only enzyme, it catalyzes the whole metabolic process, from where enzyme, you understand what is an enzyme. So we have various different kind of enzyme which we can use as a catalyst. So enzymes are the biocatalysts, you can use, say, which are basically generated from the biological precursors, or biological origins are there. And we, in the presence of that particular catalyst, whatever our microorganisms are there, they convert the starch or sugar into alcohol or acid or hydrogen anaerobically. Here also anaerobically is there. We are not using air or oxygen into it. So now fermentation is an anaerobic biochemical process. It's a biochemical process. Because why it's a chemical process? Because here the difference is, in the last process, digester process, just through this bacteria we are getting the products out of it, but there is no chemical reaction is going on. Here bacteria is doing their part. At the same time, we have enzymes which has work as a catalyst, and that whatever the bacteria generated, that chemicals are reacted with each other, and you will get a final product out of it. So that's why biochemical process. And in the fermentation, the first process is the same as a cellular respiration. Cellular respiration is like same as a anaerobic digestion or that thing, which is but in this it is known as a cellular respiration. Why? Because in that particularly glucose will be converted into the pyruvic acid. So one particular kind of acid is generated in the from the glucose. So in this process also known as a glycolysis. So that's why it is the name is given as a cellular respiration. So respiration is, we are also doing the respiratory process in our body. So like that, the whole glucose is converted into whatever the cells of materials are there. Due to this kind of process, it's converted to pyruvic acid, and pyruvic acid can be converted into the lactic acid fermentation, or there are many different kind of fermentation which we can do out of this pyruvic acid, depending on our catalyst, which is enzymes, and depending on the microorganisms. We have anaerobic bacteria, suppose, then we can go for the lactic acid fermentation, and then we will get the lactic acid from in between the aspergillus is the bacteria which we are using. If you use a lactobacillus, then you will get directly in the lactic acid, which is generally lactobacillus bacteria. When we convert the milk into the curd, then whatever we are putting the small amount of curd in our milk, and then after 2 days you will get your 2 or 1.5 days or 2 days, depending on the condition, you will get the final yogurt or curd out of it, or cheese. And that is the same lactobacillus bacteria. We can directly use it and convert it into lactic acid, or we can use another bacteria. If you have yeast, then you can go for the alcohol fermentation, where this kind of bacteria, Saccharomyces, are the types of bacteria which can convert this alcohol into the ethanol and CO2, ethanol as well as CO2. So beer and also these are the beverages like wine, beer, are also directly produced out of it. So it has ethanol in it. So this is also the same kind of process. The one thing is pyruvic acid by glycolysis, when formation process of pyruvic acid is taking place, where 2 net ATP molecules are synthesized. So what is the ATP molecules? Which is the molecules present into the cell either in the plant cell or the human body cells, we have the ATP molecules which are synthesized, and that can be converted into the pyruvic acid. So glucose goes through that glycolysis step and it provides the pyruvic acid. So this is the same respiratory cycle, and here 2 net ATP molecules is the same thing. Now the next step, pyruvate is reduced to the lactic acid, which we see. So this step, so pyruvate to lactic acid, ethanol plus carbon, whatever the amount of product which you have getting. Here NAD plus is formed, which is reutilized back in the glycolysis process. You can see the reaction here. We can see maybe in the next slide or somewhere. So NAD plus, NADH plus, H plus is give to NAD plus. What this NAD plus is that? So as basically these are the molecules which are generated in between, so which has the impact on your final product. So they are mainly consumed in the glycolysis step. Okay, so this is the slide which professor given. So based on the end product from, there are fermentation can be categorized as acid fermentation, alcohol fermentation, hydrogen fermentation. Other than that, also some types of fermentation is there. So but we just focus in this is focus on the main 3 fermentation, where acid is also not only lactic acid. There are many different kind of acid which depend on the microorganism which we are using and enzymes we are using. So but one is the lactic acid. So if you see the lactic acid, so if we can just ignore this NADH and NAD plus and ADP, so maybe I put it into some slide or something, I don't know. Otherwise, if it will be not there, then the next part of discussion we will take it into it. So this is actually the terminology which is using for the biochemical processes. So what is the ADP? There are everything has some kind of food full form. So maybe this kind of bacterial output or something is there. So from the glucose, the first step is a glycolysis. So in that this 2 ADPs got converted into 2 ATP, NAD plus converted to NADH, and then the same we can use after the 2 pyruvate what we are getting. That in the second NAD plus generation is taking place. So in the presence of all this, we are getting the 2 lactate, and the lactate, in the presence of lactobacillus bacteria, you will get your final curd from the milk. So and this lactic, whatever the curd is there, it is known as a lactic acid. So the acid is there in the the acid is present in the curd or dahi, it is known as a lactic acid. So that's why this is the process of the lactic acid. Just we are glance of the major processes, because otherwise we will not cover into the time. But if you have doubt, we will go into the detail for this, how it is look like, how it will go. So the next one is acetic acid fermentation. One is a lactic acid, another is like acetic acid. So lactic acid can correlate with the curd, with acetic acid is correlate with the vinegar. So which is the most widely used product in the food industry, you know. But at the same time, acetic acid has many chemicals can be produced out of the acetic acid. So in that the two-step process, the first step is the formation of ethyl alcohol from the sugar. So whatever the sugar we have, it is converted to ethyl alcohol from the using yeast process, the process which we use the yeast. And from this ethyl alcohol, in the second step, it is further oxidized to get the acetic acid. So one thing you always remember, if you have alcohol, so and like OH, and if we hydrolyze it in the presence of water, acidic medium if you maintain, so H2O is there, so it can give you the if you have alcohol and if you have ester material COOR, then you will get the acid plus water. So this is the main reaction. So here also from the alcohol, in the presence of this acetate or acetobacter reaction, you will convert it into the acetic acid as well as water. Another is a butyric acid fermentation. Now this type of fermentation is a characteristic of obligate anaerobic bacteria, genus Clostridium. So you have to remember, maybe some questions is there. in the assignment that which kind of obligate anaerobic bacteria. Obligate means they are the specific bacteria which we are using, which is known as a genus. Genus means the gene or a DNA or same kind of genesis of the bacteria which is known as Clostridium. There are some different different types of bacteria in this Clostridium also, but the basically their genus is considering as a Clostridium. These occur in the rating of jute fiber, rancid butter, tobacco processing, tanning of leather. So everywhere you are using this kind of bacteria. Butyric acid is produced from human colon as a product of dietary fiber fermentation. It is an important source of energy for colorectal epithelium. So if you can't able to colorectal, so if you can't able to understand this terminology, just Google it and try to understand. But it is not the professor doesn't want to ask you to as each and every small things out of this all topics in the NSEM also. So just for your understanding, and because he knows that you don't know this much technicalities. Even I am also not belonging from the biomass conversion and biorefinery, so I can also not able to comprehend what are these things are. But if you want to go into the much more detail, so these are the names. You can go into the Google and you can go into research papers, videos and all. If you want to discuss it with me, so I said my WhatsApp number and email ID in every of my sessions, so you can take it. And at the end of last slide also my email ID will be there. So alcohol fermentation is the second type of fermentation. We just saw this acid, alcohol, and the third one is the hydrogen. We just visited those three fermentation, but actually there are many more different kind of fermentation over there. But if you talk about the alcohol fermentation, the same thing, glucose will be converted into the 2-pyruvate. This is a one process, but if we use the yeast molecules, then this can be directly converted into the ethanol. So as we just saw, so glucose will be converted into pyruvate from the acetaldehyde, and acetaldehyde is reacted and converted, you will get the ethanol out of it. So we have discussed about acid fermentation. So we'll now discuss about the alcohol fermentation. It is used in industrial production of wine, beer and biofuel. So whatever kind of wine distilleries are there, whether it is produce wine, beer or any kind of that kind of different alcoholic drinks, or if you have some biofuels like ethanol is used as a biofuel, we discussed before in that. It can be like in US and Brazil, they are using 20-30% ethanol in their main gasoline, or here you can say petrol and diesel. So basically the end product is alcohol and carbon dioxide, so that's why, so it can be converted into the acetaldehyde and then carbon dioxide also released. So this is NAD plus is some kind of intermediate material which you found. It is also, or you can say that this is a kind of enzymes catalyze the process which is utilize NADH. So there are some difference in this, all this NAD, NADH are there. They are basically, I think they are enzymes. So enzyme, look, it is mentioned enzyme pyruvic acid decarboxylase and alcohol dehydrogenase catalyzes this reactions. So this kind of enzymes can be useful for the decarboxylase and dehydrogenase. So whatever the carbon dioxide removal and hydrogen removal, this kind of process is taking place. So these are the two enzymes which are responsible for doing these reactions. So if we can here, that is why if we know the whole full form of the NAD, NAD plus and NADH, then also we can't able to understand how they are reacting. So better we can think that okay, these are the some enzymes which is used for the catalyze this reactions. Now microorganisms commonly used to carry out the processes. These are the catalysis only. So processes is taken by the microorganisms. Their name is the Saccharomyces cerevisiae. Some difficult pronunciation is there. So while the feedstock used for this type of process category into three different classes: sugar, starch and lignocellulose structures. Depending on your feedstocks, you will get the final amount. And in this theoretical, what is the yield of this whole process? 51.14 gram of ethanol and 48.86 gram of carbon dioxide from 100 gram of hexoses or pentosis. Whatever the glucose you are getting, or some it comes under hexose, glucose, fructose and all, and others 5 carbon sugar is known as some pentose. So out of it 100 gram you can convert 51 gram into the ethanol, 48 gram into the carbon dioxide roughly. So now the other is the hydrogen fermentation. So here it is only mentioned by the professor that the dark fermentation is the option, but there are many more other option of biohydrogen for generation. So if you just biohydrogen production process they return, and if you just see for the fermentation, then there is not only dark fermentation, there is a one photo fermentation is also there. Dark fermentation, as you can understand, there will be no sunlight. This is a only closed environment, closed in the closed vessel is there. So which are the organism? These are just example, mesophile or thermophile kind of organisms we use, and they can generate organic acid in between, and some hybrid catalysis process will be taken place, and at the end you will get the hydrogen as a product. Another is the photo fermentation. In photo fermentation you are using photovoltaic in basic or you are using sunlight in some cases, or you are using some artificial lights. So basically generally people are using sunlight in the form of ultraviolet or sunlight in the photovoltaic cells. So it can be sulfur and non-sulfur kind of two routes are there, and you will get your final hydrogen out of it. And this is not the fermentation process, but if you want to see the biophotolysis, in that is whatever the biomass you have, you are using indirect biophotolysis, where you are directly, this photolysis process is not taking care of photolysis, in the sense you are providing the ultraviolet rays and it will be reacted. So indirectly you are providing this, and so in the presence of cyanobacteria and algae you will get your final hydrogen. If it directly for photolysis can be another option, you can directly provide the sunlight and you will get this final hydrogen as a product. So this is many more different process where we are using a microorganism from we can convert from the biohydrogen to the we convert a biomass into the final hydrogen process. And the one which is mentioned by the professor, and the very useful process in which it's a little bit looking like the complicated, but if you see here the biomass and waste we are using, and we are going for the pre-treatment. Now depending on our process, there are many different stage where we can get hydrogen. It's not like that we can only use for one process and you will get hydrogen. So first we convert it into the sugar, and there are different pathways are there. As here you can see NADH, ATP, same kind of enzymes you are using. That from directly sugar, from sugar you will get the hydrogen. So that was we saw that directly without pyruvate generation, we directly get the hydrogen and carbon dioxide from sugar. So this is also one way. Other, you generate the pyruvate, and from pyruvate you will use this different kind of catalysis material, enzyme catalysis and all, and you will get the hydrogen. Another way is you fermentation in the presence of formate kind of process, where formate means the sense fermentation process in the presence of some organisms, we directly get in the presence of this kind of catalysis you get the hydrogen. Other than that, from pyruvate you convert into the acetyl CaO, but in that you will not get the hydrogen out of it. If you go to this step, then you convert into acetylolysis, acetogenesis will be taken place, then you will get ethanol, acetate, ethanol, and other processes. But if you use these two, pyruvate and sugars, and using different kind of catalysis and different kind of bacteria, we will generate directly hydrogen. That is a final understanding out of this hydrogen fermentation. Now fermentation, okay, so this topic I think it is not covered inside. So there are two different kind of fermentation. So one is the liquid fermentation, or you can say the submerged fermentation. Another is a solid fermentation. So I am just giving you some additional information. It is you have to prepare the main part, which was taught by the professor only, but this is for your understanding. So in one solid substrate fermentation, we are using the solid material only. There will be no using some kind of solvent or some kind of liquid water, anything is not present. So from this we are putting the solid thing, and by using the microorganism catalysis enzymes, and then we'll get, you can see the cultural substrate is biomass is looking like that, and in between the temperature is maintained by the cooling and cooling plates, and in between at the end we have the soils also. This is how the spec bed kind of procedure is there. I don't want to go into the much more detail of everything, but you can see that it is a digester where you put fermenter, where you put all the solid thing, and that the process is going on. Another is a submerged fermentation or liquid fermentation, where you use some kind of liquid, so which is known as a media which we are using. So media, you have to prepare this media. It's not only the pure water or some solvent, it has some nutrition value in it, so you are using according to the required composition, and you have fed into it. In this inoculum preparation is the biomass preparation in the final process, and then this submerged, the biomass is submerged into this liquid, and the whole process is going on, and then you will get this different kind of products. Now what are the difference? So if you talk about the substrates, so mainly the biomass in the simple word, so soluble substrates, sugars soluble are there. If you go for the liquid or submerged fermentation, it needs to be solubilized. But if you have, why you are going to solid, if you have starch, cellulose and all, which will be not soluble into the simple solution, we are using water and all, so that's why you can go for the solid substrate. Aseptic conditions. So which is the aseptic condition? Aseptic condition is how much environmentally control system you can maintain. So in the liquid you have to go for a heat sterilization, and this is the aseptic control. But in the solid, vapor treatment, non-sterile conditions, so stirring can be the possible, and vapor needs to be treated. So another is water. So here liquid substrate required, as you can see, media preparation, water is used as a solvent. So high volumes of water consumed and effluents discarded. Solids, a limited consumption of water, so some amount of water is here is also required, but not this much that your material will be submerged into it. Metabolic heating, easy control to temperature in liquid, because we are providing mixing properly. Here heat transfer capacity is very low. Aeration, oxygen is required or not. Limited, if you go about the liquid substrate fermentation, the limitation of soluble oxygen, high level of air required. Air will be very high required, but limitation of oxygen. Here in solid, easy aeration, high surface extent air is required. High air as well as easy it can be go, because you can just give the air over here like this, and it will be passed to it and go out. pH control is easy in the liquid, obviously it is, stirring is possible, but solid we can't able to stir, so we have to buffer solution which has a constant pH solution. Mechanical agitation is good homogenization in the, obviously stirring is the static condition is preferred. Scale up industrial equipment is still is available currently in the liquid substrate, so many more fermentation processes taking place in the liquid only. If you see that beer, wine production and all, it will be maybe taking place into the liquid kind of thing only. It's already commercialized. But if you talk about the solid substrate fermentation, that it requires some new design equipment, and challenges are there for the engineer to be sorted out. Inoculation is the main mixture of pre-mixture of what you are generated from the biomass is easily inoculated and continuous, you can supply it, because of the phase is continuous, because you are using the liquid, so it will make a whole slurry. It's a spore inoculation batch process is there, contamination is there, risk of contamination, obviously risk of contamination everywhere is there, but here for single strain bacteria is there, low rate growth fungi is there. So fungi generation is possible in the solid. Energetic consideration, high energy consumption required liquid, obviously low energy consumption, we have to be provide the mixing and all, so everything will drain the energy. Volume of equipment, high volume high cost, low volume low cost. Effluent will be high volumes of polytic effluents will be generated due to liquid phase, no effluent, less pollution. Concentration of the product is 30 to 80 gram per liter, but if you go for the solid substrate, then the final product is 100 to 300 gram per liter of your product. So that's why solid fermentation process is still into the under the research and development stage, but once it will be commercialized, we can easily use it for the large amount of biomass conversion. So microbial electrochemical system, we just going to flip only one slide for this. Whatever microbe we have, we are using the electrochemistry, means we are providing the cell, electrochemical cell. And due to this microbial electrochemical technology, microbial is useful to convert the chemical into the another form, and then electricity will be generated, or chemical will also be generated. So here you can see the microbial electrolysis cell is looks like this, where you have in the one side you have the microbes. Okay, so if you, and that side is anode is there, ion exchange membrane. You use in between the ion exchange membrane, which can only exchange ion. Microorganism will not come this side. So you are providing the power source. So this is a directly electrolysis process is taking place, and you can get the hydrogen out of it. So if we go for the first, the plant is grown and chopped up. Okay, so plant waste fermentation is produce acetic acid, CH3COOH. So whatever acetic acid you produce, you can use it into this cell. So bacteria consume the acetic acid, raising electrons, protons, and CO2. So once bacteria consume this acetic acid, you can get the electrons, protons, as well as carbon dioxide. So carbon dioxide you can take it out from the anode. Other is at the same time you are adding some power source, because the plus and protons and electrons are generated. So greater than 0.2 volts are added from an outside source. So outside also you are applying some other power source. So because of this ionization process, whatever the hydrogen is there, hydrogen H plus is generated, and then they transfer through this ion exchange membrane, and you will get the hydrogen. And this from the cathode, it will giving it to the negative charge while we applying this power source from outside, and this negative charge is converted H plus into the hydrogen, and you will get the hydrogen out of it. You can store and it will use. So electrons join with proton and form hydrogen gas, as this looks like here. So there are many reactions. This is just for the representative thing. If you go to the reactions, then you have to remember a lot. So this is a one simple thing where you see that microorganism only in one type. But if you just see, sometimes you are using microorganism in both the places. Anodes, they are polymer to monomer, and organic alcohols are generated. Acetate, propane, and butyrate generated will helpful for generated to CO2, hydrogen, and electron. Greaseproof can be generated ethanol, 2 electron, 2H plus. Lactate will be generated as lactate plus H2 can be converted into acetate plus CO2 hydrogen. H2 hydrogen can be converted to H plus. Glucose can be converted into H plus. So these are many kind of reactions taking place with the help of microorganisms. Power source is there. At the same time, you can produce the power also. And the cathode side, you can have this hydrogen H plus in the different mode. You can convert it into the H2O hydrogen, as well as different chemicals. So mostly in the presence of oxygen. So you are providing oxygen also, and because of the hydrogen presence, final product is either water in your product, or at the end you will get the hydrogen gas. Okay, so the other process that was all about the fermentation and microorganism electrolysis we just see. Another is a composting, which is we mostly visited this into our science lectures, where we convert our waste into the final composting material for using it into our agricultural fertilizer agriculture applications like fertilizer and soil conditioners. So companies prefer an environmentally sound method where organic waste is reduced to organic fertilizer and soil conditioners. So generally, if you are using the fertilizers which are generated from the chemical fertilizers like urea, NPK, and all, by time and time it will reduce the efficiency of our soil. So if we are using this organic, generally people are now using organic material you are finding into the supermarkets and malls. So organic these vegetables and organic fruits. So how they are generating, we'll be using this composting material. So basically it has 3 phases, and you are using microflora such as bacteria, fungi, any kind of thing, mesophilic, as well as mesophilic as well as thermophilic microorganisms, which can be convert into organic waste to humus. So this is a intermediate humus. It's the first step. During the is the final thing. During the first phase, there is an increase in the carbon dioxide along with the temperature. The substrate is reduced due to the degradation of sugar and proteins by the action of mesophilic organisms. So if we are using mesophilic organisms, sugar and protein will be degraded. Substrate will be biomass is degraded into sugar and proteins. Then the second phase leads to an increase of the temperature. In the first increase in carbon dioxide and temperature both. In the second, the only temperature is increases from 45 to 70 degree, and mesophiles are replaced by the thermophiles. So the another kind of bacteria which can be sustained at temperature and do their work will be come into the picture, and they will do the one process. So if you go to third phase, okay, I didn't mention. In the third phase, you will get the final product. So food waste source, you are using any agriculture, commercial, residential, and transport it into the land. So you can directly go for the landfalling type. This is still not effective option, and we can put it into the composting. Where composting, you can see that ammonia, methane, water, everything is got generated, reduced out of it, and at the end application you will increase the soil property, plant productivity, and supply nutrients as you are using a fertilizer out of it. Now I don't want to go to much more detail to the each and every process because we have limited time. So we have only 3-4 slides are remaining. In that I just touched to the concept of equipments. So why didn't I went through the equipment process in detail? Because professor has the other chapters, he mentioned other lecture of this particular week discussion, he mentioned many processes in detail and some commercialized technology also, but most of the questions were from this fundamental things, and in your final exam you can't able to remember all the bacteria processes and all the chemical reactions and out of all the final commercialized technology also. That's why you have to focus on the major fundamental things, and due to limited time and the assignment focuses and exam focuses on the fundamental things, we covered this one. So this is the equipment. If we go with the bioreactor or the fermenter, in that if you can see, this is a liquid and this is a motor is there where you are getting this impellers, particular kind of impeller, and not more than one at different height of the impeller, where this is used for the mixing. You have the baffle in between, and the temperature is maintained by the cooling water. So cooling water will be go there, and some temperature is increases, so this cooling water is required for maintain the temperature. Then in between you can see the culture is the whatever the in between intermediate stage of your biomass, which in the presence of water, liquid sticky material is formed. It is known as a culture. You are as you have to, if you have to supply the air or anaerobic in sometimes if you require air, then air will be going through this Sparger is distributed that air, high pressure air. If you want to maintain the temperature, then steam is there, and pH is maintained. pH control is there for maintaining the pH, and if you have the pump are there in between if you want to add the acid base material, if you want to take out, or if you want to add. That's why and how it is looks like industrially, it is actually looks like this. It is very complicated, but everything will be maintained by the computerized system, which is generally known as generally most of the process used as a SCADA, so supervisory control and data acquisition system. So maybe you learned all these things into the process control and all. So the most commonly used configurations are conventional anaerobic reactor, such as the anaerobic sequencing batch reactor, and the continuous stirring reactor, and anaerobic plug flow reactor. So these are the 3 different kind of reactors. These are the most general. There are many more different categories, different kind of reactors are there. Then the second category, if you talk the sludge retention reactor, such as anaerobic, first is the conventional anaerobic reactor. In that, anaerobic sequencing batch reactor, continuous stirring reactor, and plug flow reactor. You can consider like this. If you go for the sludge retention reaction, then anaerobic contact reactor, upflow anaerobic sludge bed reactor, and upflow anaerobic solid state reactor, and anaerobic baffle reactor, and the internal circulation reactor. There are many names are there. So that's why you can't able to remember each and all things. So if you talk about this bioreactor, so there are 2 different things, bioreactor and fermenter. There is slight difference in it. Actually, fermenter is also come under the bioreactor because biochemical process is going on in that also. but this bioreactor mainly doesn't have this other processes. The ferment has little bit difference, so we'll go through the difference also and some part of all both of this reactor. That's it for the today. So this is our medium, or you can see that whatever the inoculum you collected from the biomass, and in the presence of media or liquid you convert it into the solids, this slurry. Steam is added and you are increasing temperature as air is supplying. Cooling water and thermal jacket, as we see that it will be helpful for maintaining the temperature. Then sensors are there everywhere, and the agitation is provided, and pH control and other different control and pressure gauges are there. Now if you just see the main important uh, part of the reactor, then there are many things, but majorly there are sealing assembly. So if you can see here, everywhere sealings is there, sealing is provided. So for the proper agitation and all. So here mechanical sealing is there. For mechanical sealing there are mainly three different kind of sealing. However, this is a mechanical design point of view: packed gland seal, mechanical seal, magnetic drives. Other than that, baffles are there. Some questions are there in the assignment, and maybe in the exam also it will become. So what are the usefulness of the baffle? The major usefulness when we are providing the uh, usefulness or advantage when we are providing this stirring. So it is generating the vortexes, and after some vortex, if we consider this kind of liquid is going there, if it will convert it like this kind of vortex, then the mixing is not proper, as well as the reaction will be not taken place properly. So that's why baffle will be there. So they are cutting down these vortexes, and it will be not formed, and the proper mixing will be divided. And it has a metal strips readily to the wall. So other than that, here it is not properly mentioned the baffle, but in the last figure you see that it is currently it's mentioned like this. And the baffles is also give the strength to the whole reactor. They are useful for the heat transfer and mass transfer of the process. Impellers, as this particular impeller which we saw, it's for uniform suspension of microbial cells, because you stirring provided. Due to this stirring, the uniform suspension of slurry will be there, and they are made up of the impeller blades attached to the motor under it. Obviously we are providing the motor, and it's a very simple explanation. Impeller blades may play important role in reducing the size of air bubbles. There are different kind of impeller designs are there, so we have to take into consideration according to our uses. Variable important use are in the fermenters. This turbines variable pitch open turbine. Other is a sparger. So in the bottom here we are if you want to sparge the gas, air or something in the down, so it is nothing but as a metal plate, and if we provide into the air or another medium, air gas medium, and we pressurize the gas into it, and it will come from this holes. So this is a sparger. It's used for the introducing sterile air to the fermentation vessel. It helps to providing proper aeration, and these are the dimensions. You don't need to remember this, just for the information. Porous sparger, nozzle sparger, and combined sparger agitation. This kind of different types of spargers are there. Feed pots, they are used to add nutrients, acid, alkali to fermenter. As we see, there are addition of the acid, and another separate line is there, or you want to add microorganism in between. So these are the feed pots, so where you can use this. It are made of the silicon, so that's why it will be not reacted with the acid and alkali. In situ sterilization will be performed before the removal addition of the products. So sterilization, for the sterilization also speed for sterilization means the removal of the any unnecessary material out of which sterile. Foam control, because generation of foam is easily can be generated, because if you go for the whole liquid kind of thing, then we have to avoid the contamination. This, if foam will be lower down, then contamination will be lower. There is important factor. So foam setting and control we have to mount in it. Valves are there, definitely different kind of valves which we may be studying in the fluid mechanics. Globe valve, butterfly valve, some control valve is also there, and at the end safety valve is also there. If the process pressure temperature goes high, so safety valve will reduce the pressure, and then will be your process will reactor will be not busted out. So if you just see the fermenters, then also it's not only single kind of fermenters. So batch fermenters, continuous fermenters, and recycle fermenters are the major category. out of it airlift bioreactors, tower fermenter. In the tower fermenter, there is a bubble column reactors as well as bubble cap reactors, plug flow reactors, packed bed bioreactors, fluidized bed bioreactors, stirring bioreactors. There are many kind of reactors. So as you can see, this is a star tank reactor. This is a bubble column. This is a bubble cap reactor, where bubble. You can say this is a tray kind of packed bed. It is a properly packed bed reactor. So this is different kind of reactors are there which we can use. These are the general chemical reactions we are using. That kind of reactor we can use it here for the fermentation also. Now bioreactors versus fermenter. So as I told you, this is a two different thing. There's a slight difference in between. So if we talk about the definition, then bioreactor is a closed vessel that facilitates different types of biochemical reaction. Any kind of biochemical reaction if you are performing, then it is a bioreactor. If we just talk about a fermenter, it's a bioreactor. It is a subtype of bioreactor, because any type of biochemical process is going on in any kind of reactor, it is known as a bioreactor. So fermentation also is a kind of biochemical process, so it is a bioreactor, but it is specialized only to carry out fermentation. If we just use a fermentation for it, then it is a fermenter. So there will be no much more difference. That's why professor also mentioned both the same only, but they slightly change. Type of reaction, any type of biochemical process, fermentation process. Products, many kind of process. Pharmaceutical products also sometimes use bioreactor for generating your drugs, but here you can only generate after fermentation products are acid and alcohols. Type of living organisms, you can use animal cell, plant cell. Here you can use a fermentative microbes. Oxygen requirement, it can be requirement or not, anaerobic and aerobic condition, but the fermenter is always in anaerobic conditions. So we just talk about the microbial fermenter, animal cell culture bioreactor. Then application is, so you can here use the microculture mechanism, culture of animal cells. Types of products, so you are generating the vaccines and particular kind of things where we are using a bioreactor, then we are using. So this is a very specific example. You don't need to go into the kind of thing, but just for the difference. So what are the height and diameter? This is also difference. Agitation design is different. So we also don't want to go to much more detail. You can read or you can neglect also. But gassing requirement, how to you provide the gas air. So it is oxygen, sparger and all. It has a different amount of sizes for both the process. pH control is dosing pumps and valve are required. Dosing bottle, dosing pump and valve group. I mean, little bit changes there. aeration for ring sparger, here you go to the micro sparger. Media sterilization is using steam. Here you are using the pressurized bioreactor. We have to maintain the sterilization is utmost continuous operation. Partial harvesting and fresh media. So how is the process taking place? So these are somewhat differences that. So this we reach at the end of the today's discussion. Sorry if I took much more time, but I was supposed to take 2 hours. So anyway, this is much more we discussed than required. So unfortunately I didn't cover many more other aspects to go into deep into the processes and types of reactors and go into deep into the commercialized process, but that is all everyone can get to know from the professor's slides. Also there are too much information, so I just take that some information from his slides and another much more information from my end. So I want to conclude. This is my mail ID. If you can want to contact me, you can use it. And I want to conclude with the famous quote from the Srinivas Ramanujan, that an equation means nothing to me unless it explains the thought of God. So I always added 1 or 2 quotes from the from famous personalities. So some people are born talented like Ramanujan. So he has that kind of subconscious level intelligence that he doesn't need to learn or understand something. It looks like it is too much easy from him, and he is believing in some Devi Ma in his near to his home village. There is one Devi temple is there. So he thinking like that, everything equations and everything is for me, it's less like the expressions coming from the God. So everything is coming from the God, and I am just putting it into the pen and paper. That's it. So I'm not here targeting any kind of thing from this statement, but I'm telling you, okay, if you are following in your patience and all, then you have to just stick to your hard work. Everything will be come from the God and the believing entity which you follow. So just do the hard work for your thing. And I just want to stop sharing, and with this I want to conclude the today's lecture. So if you can, and if you have any doubt, you can reach out to me in my mail ID as well as WhatsApp contact number. And have a happy, safe and good holy festival. Nice to meet you again into the same kind of discussion in the next week. Till then, goodbye.